Okay, so the final thing we have to talk about today is the integration by using reduction formulas. So these basically have sometimes you have integrals that have really high powers and they can take forever to deal with. However, a reduction formula is basically when you generalize the case. For example, if you can say, for example, if I is equal to integral of sine to the power of 7x or something like that, if like for example, like if this is I7 or something like that, and you have a result that says when you integrate I to the power of n, you just get a certain result like cos nx minus I n minus 2 or something like that. You can therefore have a generalized case where you can then simply repeat the pattern over and over again to find the actual integral. So here's an example. Let's say in is equal to the integral of cos x to the power of n. You can prove that you can express this integral, the result of that is equal to cos n minus 1 times sine x over n plus n minus 1 over n I to the power of n minus 2. And then hence, using this reduction formula, you can easily find the integral of cos 5 to the power of x. Cos x to the power of 5, I should say. So the way, there was a typo here, so be careful. The way we do it is we split cos n to the power. So what we do is in is the integral of cos n x dx. So what we're going to do is we can split it as cos x, cos n minus 1 x. So this is, so ignore that n minus 1, there's a typo there. So what we can do now is we can let u be equal to cos n minus 1 x and v dash be equal to cos x. And now we can use integration by parts. So u dash is n minus 1 cos n minus 2x, but don't forget the chain rule. So it's going to be a minus sign multiplied to that. The derivative of cos is negative sign. And for v, it's going to be sine when we integrate cos. So this integral is going to be uv. So sine x is going to be cos n minus 1 x times sine x minus the minus cancels out with this minus sign, so it will be plus integral of if I take out the n minus 1, integral of sine x times what's written here, n minus 1 times the sine x times we are doing this thing here. So notice how there are two sine x's. We got this sine x here with the cos n minus 2x, but then we also need to multiply with that sine x as well. So what you end up getting is you're going to get sine squared x dx like that. And the way you continue doing this is, notice how this is sine squared x. You can convert that in terms of cos. So this will be 1 minus cos squared cos n minus 2 x dx, like so, after you apply integration by parts. And then when you proceed, you will get n minus 1 integral of cos n minus 2x minus cos x. Notice how cos squared x times cos x to the power of n minus 2 will just become cos x. So when you break this up, this will be cos n minus 1 x sine x plus n minus 1. Remember, we said that in is the integral of cos to the power of n. So when we integrate cos, just looking at this one by itself, when we split this up into two fractions, it's going to be in minus 2. And here we've got minus n minus 1, another cos, integral of cos x, which is going to be in. Oh, this is n here. So therefore, I can now take this to the other side. I can take this to the other side, and I can say that n minus 1 in plus in, because remember on the left-hand side we got an in, is equal to cos to the power of n minus 1 x sine x plus n minus 1 in minus 2. So therefore, we can factorize out in. So this will be n minus 1 plus 1, which will just be simply n. So on the left-hand side, it will be n is equal to this entire thing, which I have here. So therefore, we can say that in, we could just divide everything by n, is going to be cos n minus 1 x sine x over n plus n minus 1 over n minus 2 as required. So this is, you can see how recursive it kind of was in terms of you got the original integral and you had to take it to the other side after we did integration by parts. But now that we got this result, to find cosine x to the power 5, or, this is the steps written. Just remember there was a typo here, that was cos x. Once we've done that, to find cos x to the power 5, remember that's just going to be I5. So you just apply this formula. Just plug in n equals 5 here. So you'll get cos 4x sine x over, this should be, that should be 5 over 4 over 5. So there's a typo here, that should be 5 there. So just be careful. There's some typos on the slides here, but yeah, you could just plug it in. That would be 5. And then afterwards you get I3. And then to find I3, you could just apply the formula again, recursively, just plug in n equals 3 instead, and then you can just directly go from there. So you just use the form. This is useful. Now that you have this reduction formula, you can simply just apply it over and over again whenever you need it to help. Whenever you have a question where you need to have like high powers, you could use it to bring down the powers. Okay, so we are well and truly over time. So that brings us to the end of all the integration topics we'll be talking about today. So there are a few more integration by reduction formula questions, which you can have a look on the site in your own time. And just